Okay, so now I have a radical equation. So I've got this radical symbol in here, and ultimately, just like in quadratic equations in vertex form, we're trying to get the parentheses alone. In here, we're trying to get the radical by itself. And once we do that, we can square both sides to find the answer. Radical equations have one answer. Okay, and the reason for that is the graph looks kind of like that. Okay, so um, if we start by doing PEMDAS backwards, okay, when we're trying to solve something, we always do PEMDAS backwards, or we undo things furthest away from the x. So we're going to get rid of addition and subtraction first by adding 5 to both sides. And then I'm left with 3 root 2x plus 1 equals, and then we end up getting 53. Feels like weird numbers. That's okay. Then I'm going to still get that radical by itself. So I'm going to divide both sides by 3. And I get root 2x plus 1 equals, and 53 divided by 3 is, it rounds to the nearest 10, 17.7. And now my radical's by itself. So I undid my addition and subtraction. I undid my multiplication and division. Now I've got to get rid of the exponent. Now we don't really think about radicals as exponents, but another way to write something being square rooted is something being raised to the 1/2. Now this is not something we're really going to go into, but all this does is it shows you that a radical really is just a different type of exponent. Okay, so now to undo taking the square root of something, I'm going to square both sides. And I get 2x plus 1 equals. Now squaring something isn't going to give us two answers, so we don't need to do plus or minus. So 17.7 squared is 313.29, which rounds to 313.3. And now I've got a two-step equation, an equation we've been solving for a while. So I'm going to subtract 1 from both sides, and I get 312.3. And then I'm going to divide both sides by 2. And when I do that, I get 312.3 divided by 2. I get 156.15 or 156.2. So what this means is this is where this equation crosses the x-axis.